Hello everyone. Alright, this is going to be the second part on a video on BAVSA, the binaural beat visual analyzer software. And in the first video, which was rather long, we went into a lot of details about the interface. In this one, we're going to look just more closely at how to do a little bit more complex track, although we're still going to work with inside of a sandbox. So you'll want to review the first video if you haven't watched it, just to get an idea of how to use the interface and what BAVSA is. So here we have the same track that we used for the first video, where we have a binaural beat at a pitch of 180, starting at 10 hertz, jumping to 11 hertz at 4 minutes, jumping down to 7 hertz at 8:27, then ramping up to 9.5 and exiting. So what I've done in this video is I've added a Thought Sounds soundtrack. So that's basically just the first one in the Thought Sounds soundtrack. If you wanted to analyze that one, then it is Thought Sounds Sample 1 in Program Files, My Workstation Resources Sounds. That comes with the program. So it's just a loop of that. All right. And I've already exported it as a wave, which you have to have a wave for BAVSA, and opened it in BAVSA exe to analyze it. And this is the analysis file. And then now we'll just go into the BAVSA view and take a look at what we've got. All right, so here's that. And as you can see, it's much more complex than the first one that we saw. There's a lot more peaks throughout the spectrum. Just one thing I didn't really make totally clear, I think, in the first video, was these two axes here. All right. Now we did realize that this is the frequency axis for the binaural beats. So this would be the entrainment axis, basically. And then this is a frame axis. All right. The frames are 5 seconds long. So what you see across the whole screen is a frame representing 5 seconds of audio. And we're at 4:03 in that one. At 4 minutes and 3 seconds in this, because I've already played with it a little bit. But this is the frequency axis for the pitch here at the top. So we're looking from 0 hertz for the pitch up to around 700 or 800 or so, around there. The BAVSA documentation says it'll go to 1500, and that's about the range of binaural beats. So that's the reason they choose that. But this is the pitch frequency axis. This is the entrainment frequency axis. All right, so let me just go ahead and get us back down to the start. Remember, I'm using page up to do that, just to quickly scan through it to get to the beginning. You could also use the backspace key. Now, this looks a little bit more familiar as a spectral display, but we're seeing these stacked pitches. So if you could imagine this turned around counterclockwise 90 degrees, it would start to look a little bit more like a spectral analysis that you're used to seeing. Now keep in mind that I have this one set at the L key, K, J, which is J that we use the most, H, G, and F. But L's useful in this case, just to initially see the beat. Now what we're looking for amongst all of these colored peaks here is we're looking for something outstanding that is in one channel, a prominent feature, but not the other. Now again, this is a sandbox, so we already know where we're looking. But there it is. There's the binaural beat, and it's extremely prominent. Now keep in mind, with the number keys, I can reduce the actual brightness of the spectral display to target certain areas. But even though we're in a sound file, and let me go ahead and play that sound file. I didn't do that. Probably heard it a million times if you use the transparent software. But that's just a sound file track with our binaural beat track. And our binaural beat is just at the default volume of 20. So it's not extremely loud, but it's maybe more loud than it would be in, say, a commercial track, just a little bit more loud. But it stands out very, very prominently in this test bed. In audio that you actually analyze from other sources, you're not likely to get this lucky. Now, I do want to point out again that if we go ahead and we raise it back to where it was, that's 7, that's 8. So 7 is useful. Now keep in mind that, as I said in the first video, that as you move your mouse along, you're measuring it at the bottom. All right. Now that's saying 182.55. See, you want to get at the very tail end of it, just right beyond the darkest blue where it first starts. That's the lowest pitch point. And at that point, it's going to be measured accurately at 180 for 10 hertz. Right here at this blue point. Now that's why you use the J key, because the J gives you a above view. So let's go ahead and zoom in to that area and see it's harder to see amongst this group. That's why you use these other displays, so you can target it, so you know it's right there. See, it's right there. So you would just begin to track along here. Now, being that this is an above view, it's going to give you some information on that at the bottom. So if I go to the white area, which is the area of most concentration, let's go ahead and zoom in even more so we could see that what's actually happening is these colors are layered together, basically. So you're getting the full range of the colors, and that's where you use the number keys to reduce it. See, get rid of some of the whites and see more of the lower bands. Now, if you switch to that view, you can see what we're actually doing with the brightness. See, we're getting more of the gradations between the volume levels. That's what that is. That's a volume level of the prominence of the peak, really. I suppose it's more of a prominence measure. And then back to J, and we can see that. So let's go ahead and zoom back out with our X key. All right, and so see, that peak stands out prominently amongst all the others in relationship to how strong it is compared in the source. So that is our beat. So if we follow on through with page down, in this case for spacebar, 1 minute, just over 2 minutes now, and see it staying solid. It's not changing. All the other audio around it is changing ever so slightly, and in some cases more or less. One thing about the binaural beats too is if somebody tells you it's a theta track or whatever, you know where to look. Now, we've artificially created this so we know exactly where to look, but you're also looking lower usually. If you can't hear a high-pitched binaural beat, then you're looking lower in the frequency spectrum here. So sometimes that can help to know where to target. Up here at 40 hertz or whatever, you're not going to have binaural beats because you can't really produce them above about 26 hertz or so. So you're always concentrating generally around an area, say from 100 or maybe even 80 to 400. In 400, I think you'd prominently hear it because it's a high pitch. All right, so let's continue on. We're going to go up, 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 and it's at 4 minutes that we see our change. So I'm going to go down a little bit. All right, so if we were measuring that at 10 hertz right there, and then we continue to go forward, we could see the shift right there. See, it shifts positions. So that tells us that it's 11 hertz. Now again, look where I'm measuring, at the point of the very base. All right. So if I hit J, I'm measuring there. And then L will bring it back out. So that shows our point going throughout. Continue to go through the session. Now we know this session, so we're just going to jump to 8 minutes or so. 8:37, I believe it was. Yeah, right there. And we could see the jump down. And go backwards. Right there, the jump down. So again, we measure, and there's 180. So we're able to keep continuing tracking. Now we're at the point where it'll start to ramp. Okay, so we'll just watch it move. Just keep holding it down. You can see it climbing. That's why you just want to keep your mouse cursor at a static position. Then you can watch the change from where it first started. So that took us to the end. So let's measure here. And it's saying it's 180, 9.2, 13 minutes, 13 minutes and 10 seconds. Okay, so 180, 9.5. Thereabouts. You know, you'd have to, again, we talked about that in the first video. J is the way to really get accurate with it. So I just wanted to show you that different display to show you a binaural beat inside of music, that this BAVSA software still pulls it right out, although again we're at a more simple type of sandbox display where there's not a lot of frequency changes, and most tracks there's not going to be. Most of them are fairly static, and most of them will label them beforehand to be a theta session or alpha session or what have you, so you can look. But this will show you what it looks like in the context of music, and it's a good test to understand. I think I'll make some more videos about, and we'll deconstruct a actual other session that someone else has created that's unknown, and I won't know what it is. We'll do that at some point. Anyway, I hope you enjoyed that.